Hey guys, we're back again in 9.4. I guess I should have notated that this is 9.4. And we're going to be looking at question 15 from that homework. Colin asked this question, so thank you, Colin. We're asked to find the most precise name for each quadrilateral and then find its area. So let's start by first just placing that quadrilateral on the coordinate grid. So I've placed A, B, C, D here, and what it looks like is a rectangle, but we can't just go based off what it looks like. We have to prove it mathematically. So the first thing I'm going to do is check, is AB parallel to DC? And the way that we can do that is using our slope, because we know that parallel lines are going to have congruent slopes, or the same slope. So we know that slope is rise over run, so my rise is actually -3, and then my run is 5. So we get that slope is -3/5. And then if I come down to D to C, I went down 3, I go over 1, 2, 3, 4, 5. So we see that that slope is also -3/5, and that proves that AB is in fact parallel to DC. So we can draw those little arrows to notate. Now we're going to do the same thing to check if CB is parallel to DA. So I'm going to do my rise and run there. So mark off. I'm going to be going here and there. So my rise was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Vertical change of 10. And a horizontal change of 2, 3, 4, 5, 6. So since it's rise over run, we know that the slope there is going to be 10 over 6. Or that reduces down to 5/3. And we'll discuss what we just should have realized there in a second. D is going to come up and then over. So we see how far did it come up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's good. And it went over 1, 2, 3, 4, 5, 6. Same as my line CB. So what we see here with this slope being 5/3 compared to the slope of -3/5 is that they are opposite reciprocals. So that means that they are in fact perpendicular to each other. So I can go ahead and notate down here that this is a right angle. So since we see that they have the parallel relationship and their corners make right angles, we know that this is in fact a rectangle. So from there, to find the area, we just need to have the length of this edge and the length of this edge. So I'm going to pause the video to set up a little bit of work, but I will be right back to discuss how we can use either the Pythagorean theorem or the distance formula. They're essentially the same thing, but I will be right back to explain those two things. Alright, so now we have determined that these are perpendicular to each other. We've determined that this is a rectangle. Now we need to determine the lengths of the edges. So I've set up my distance formula here, and essentially your distance formula is a manipulation of the Pythagorean theorem. It's just your change in y squared plus your change in x squared. Well, my change in y is just the long leg of my triangle, and my change in x is just the shorter leg of my triangle. So we already know that my change in y is 10, and we know that my change in x is 6, so I'm just going to fill in 10 and 6. Now, we could have filled in what the y value was, and the other y value, and the x, and the other x value, but that takes longer. Mathematicians, we like to be efficient. So now I've got my 10 and my 6. I need to square both of them. 10 squared gives me 100, and 6 squared gives me 36. Now, if you're good at working with radicals, right about now you might be realizing, this is not nice because square root of 136 is approximately 11.66. So, ignore your 11.66. See, can we just work with the radical number and get a good answer? So for now, just know that we have radical 136. We could approximate it with 11.66, but we don't really need to. So now if I go to find this unknown length, I'm actually going to use the Pythagorean theorem to solve that, and I have my short leg and my long leg. So my Pythagorean theorem tells me that my length the length of my hypotenuse, is going to be my leg squared plus my other leg squared, but that's my length of my hypotenuse squared. So eventually we will have to take the square root of it. So working down, I still have that length squared. I plug in my 3 and my 5. I square both of them and get 9 and 25. I then sum those and get 34, but remember that's my length squared. So I take the square root and I find another radical answer, so I have radical 34. So now I see that this length is radical 136, and this length is radical 134. So what happens if I just multiply those two values with each other? Well, radical 136 times radical 34 gives me a perfect integer of 68 units squared. So Colin, that would then be the area of this rectangle is just 68 units squared. Hopefully that helps you in trying to determine what the shape is. Now, if we found that these weren't perpendicular, but still we had parallel lines here and parallel lines there, we might have had a parallelogram, or we might have a rhombus or a trapezoid, depending on what we find. But this one worked out nice and easy, became a rectangle, and then solving the area was easy. So if you have any other questions for me, please let me know. Aside from that, keep working hard, and we'll see you soon.